Welcome back. I hope that this video finds you and your loved ones healthy and doing well and in good spirits. Before we get going, Miss Andre and I just wanted to reemphasize how much we appreciate the time and attention that you're throwing into your schoolwork during this difficult time. We know that the circumstances aren't ideal, but we really appreciate you rising to the challenge and giving it your best shot. So kudos to you guys. We miss you. Believe me, we really, really miss you. All right, so now to the fun stuff because I know you're excited about getting into the geometry. In this video, what we're going to do is kind of take an old idea and expand it or run a little further with it. So we talked earlier in the unit about using similar triangles or similar polygons to find side lengths, and we're going to kind of kick that up a notch to the next level. So here's what's different. When I look at that first example, upon first glance, I really only see one triangle, but when I look at things a little bit more carefully and a little bit more closely, I notice that in the picture there's not one triangle, but two. There's one that's orange and there's one that's purple. And I know that in order for triangles to be similar, I have to have two pairs of congruent angles. So I'm going to go in search of those two pairs of congruent angles. Well, notice, and this is the piece that's new, this is the piece that's different. Notice that that blue angle is an angle in my little orange triangle, and the blue angle is also an angle in my purple triangle. In other words, that blue angle is an angle in both triangles, and that is the reflexive property for angles. But that's only one pair of angles. We're going to need to use our properties of parallel lines to find the other pair. And for this, you're going to need to think all the way back to quarter one when we talked about parallel lines. Notice the arrows going in the same direction on those two sides. Those arrows tell you that those lines are parallel. And remember that whenever we have lines that are parallel, we have some congruent angles that are formed. For instance, we have congruent alternate interior angles, and we also have congruent corresponding angles, which is the scenario that we have going on in this picture. We've got the red angles that are corresponding angles that are going to be congruent in both the purple and the orange triangle, and that's what makes the triangle similar. So these triangles are similar by angle-angle similarity, and that tells us then that the sides are proportional. And one trick that I like to use whenever I have one triangle sitting on top of the other, when I look at the picture I see that little orange triangle sitting on top of the bigger purple triangle, is I like to draw those triangles separately. So I'm going to draw my little orange fella, and I'm going to draw my bigger purple fella. The blue angle sits down in the bottom left corner of each. The red angle up at the top of each triangle. And now the left side of the orange triangle is 4. The left side of the purple triangle, be careful, is made up of that 4 and the 8, or 12. The bottom side of the purple triangle is x. And the bottom side of the orange triangle is going to be a little tricky. I have the whole thing, which is x, but I want to take out that 14, making that side in my orange triangle x subtract 14. And that, folks, I think is the trickiest part of this, is separating these two triangles, because now I've drawn these in such a way that my corresponding sides match up, so it's going to be pretty easy to go ahead and to write my proportion. When I write my proportion, I like to put small over large, but you can put however you'd like to. I'm going to put 4 from the small triangle over its corresponding side 12 in the larger triangle equals x minus 14 over its corresponding side x in the larger triangle. So again, I'm thinking side in the small triangle over its corresponding side in the large triangle for each of those ratios. And now that I've got my proportion, I'm going to go work my magic and do my cross multiplication. So 4x is equal to 12x. Be careful when you do distributive property. I distributed the 12 to the x, but I also have to be careful and make sure I distribute the 12 to the minus 14. I have a couple different ways I can go here. I'm going to subtract 12x's from both sides. And now when I divide both sides by minus 8, I find that the value of x is equal to 21. Beautiful. All right, number 2, I'm going to go take a look at this one. Notice that in this picture too, I have two different triangles. I still love the use of my highlighters. That hasn't changed, or my colored pens. So there's the red one, and there's my blue one. Notice that that orange angle that they share up at the top is the same in both triangles, so that's your reflexive property for angles. Notice these lines that are parallel. Like in the first example, they're going to have some congruent corresponding angles. And it could be that angle on the right side of each triangle, or you could even, for these, use that angle on the left side of each triangle. Either one of those would work very nicely. But again, my strategy, like with the first triangle, is I'm going to go ahead and I'm going to separate these two triangles. So there's my red one, there's my blue one, there's my orange angle at the top of each. My congruent yellow angles are in the bottom right, and my congruent purple angles are in the bottom left. And when I go to label my side lengths, looks like the right side of the big blue triangle is 12, and the left side of the big blue triangle from the picture is 15. And in my red triangle, the right side is 4. And again, in my red triangle, the left side is x. So again, I've got those triangles that are similar by angle, angle, similarity. And because the triangles are similar by angle, angle, similarity, the corresponding sides have to be proportional. So I'm going to go ahead and write a proportion. And again, I like when I set my proportions up, I will almost always do the sides in the small triangle over the corresponding sides in the large triangle. But you could put the sides in the large triangle over the corresponding sides in the smaller triangle as long as you do the same for each of your ratio. So x, the left side of the red triangle, over 15 in the blue triangle, equals 4 in the red triangle over its side 12 in the blue triangle. And again, I've got this whole proportion working, so I'm going to solve this by cross multiplying. 12 times x equals 15 times 4, or in other words, 12x's are equal to 60, and each x is equal to 5. Beautiful. Number 3 is a lot the same. In this particular example, again, I've got two triangles which sit one on top of the other. So there's my larger green one, my smaller pink one. They share this little orange angle down in the bottom right-hand corner. And they have a pair of angles that are right angles that are congruent. So these triangles too are similar by angle-angle similarity. So I'm going to go ahead and pull them apart. I've got the big green one, and I've got the littler pink one, each with a right angle, and each with that orange angle in the bottom right corner. And now when I go to fill in some side lengths for the green triangle, the bottom of the green triangle is 24. We're trying to find segment AB, so I'm going to label that X. That's the left side of the green triangle. And in my pink triangle, the bottom side is 12, the left side is 5, and it looks like that hypotenuse is 13. Again, I've got two angles in the green triangle congruent to two angles in the pink triangle. So the triangles are similar by angle-angle similarity. So what that tells us is that the sides have to be proportional. And again, I like to put the sides of the small triangle over the sides in the larger triangle. So I've got X over the left side in the pink triangle, which is 5, equals 24 over the bottom side in the pink triangle, which is 12. And just in case any of you are wondering where that 13 went, notice that I don't have a corresponding side in my green triangle. So that's kind of extra information that we don't need in order to solve this problem. So now that I've got my proportions set up, I'm of course going to go ahead and cross multiply. So 12x, the product going in one direction, equals 5 times 24, the product going in the other direction. Or in other words, 12x's are equal to 120. And each x then is equal to 10. And notice that this question says to find the length of AB, but it just so happens that I called the length of AB x. So I could either leave this as x equals 10, or if I wanted to be a little bit more clear about what the answer is, I could write AB equals 10. But either of those would be correct, because I can see from the way that I labeled the picture that x is indeed equal to 10. All right, last question. This one I think is a little tricky, but we'll go ahead and we'll make sure that we have some fun with it. This one, unlike the others, doesn't have triangles that overlap. This one just has a blue triangle up here at the top and a pink triangle down here at the bottom. There are no shared angles between these triangles. However, at point C you have those vertical angles that are going to be congruent to one another. And the parallel sides on the top and the bottom are going to give you some congruent angles. D and B are going to be congruent because they're alternate interior angles. And you might be saying, well, wait a minute, E and A are congruent alternate interior angles as well. And if you spotted that, good eye, you're exactly right. And what I'm going to do, since it's kind of tricky to see from the way that this picture is drawn, the pieces or the sides that match up with one another, is I'm going to redraw them. But when I redraw them, I'm going to keep triangle ACB exactly the same. And notice that in triangle ACB, C, my orange angle is at the top, B, my purple angle is in the bottom right, A, my light blue angle, is on the left. And when I draw my other triangle, I'm going to match them up exactly the same way so that their pieces or their congruent angles match up. So I'm going to put the orange angle up at the top because it was on the top in the red angle. I'm going to put the purple angle in the bottom right because it was in the bottom right in the red triangle. And I'm going to put the blue angle in the bottom left because it was in the bottom left in the red triangle. So if I go look at how these should be named, C now is the orange angle, E is the light blue angle, and D is the purple angle. And that's important because I always want to draw these in such a way that things will match up to each other. And now I can go ahead and I can label my side lengths. So the length of CD is 3, the length of DE is 5.2, and in the red triangle, the length of BC is 6, it looks like, and the length of AB is X, which is what we're trying to find. I know these triangles are similar because not just two pairs of angles, but in fact all three pairs of angles are congruent. So these triangles are similar by angle-angle similarity. And because these triangles are similar by angle-angle similarity, the sides have to be proportional. So I'm going to go ahead and write a proportion that matches up their corresponding sides. And again, I'm going to use small triangle over the corresponding side lengths in the large triangle. So 3 over 6, its corresponding side in the larger triangle, equals 5.2, the bottom side of the blue triangle, over x, its corresponding side in the larger triangle. And now that I've got my proportions set up, I'm all in good shape to go ahead and cross multiply. So 3 times x equals 6 times 5.2. Or in other words, 3x is equal to 31.2. And each x is 10.4. Folks, thanks so much for watching. You and your loved ones stay safe, stay healthy, try to stay positive. And again, I know Miss Andre and I are very much looking forward to the time when we're able to get back together and come together as a class. Till then, we're going to keep on keeping on and doing the very best we can. Thanks so much for all your hard work, folks. We miss you.